Determine the sum to infinity of the following infinite series. Let us begin. So here we have an infinite series. We're going to name this series as S infinity, which means that we have a sum up to infinite number of terms. So it's given here. We have the first term as 1, followed by the second term, which is 2 squared divided by 3. Then we have the third term, 3 squared divided by 3 squared. Added to, we have 4 squared divided by 3 cube. Now, this particular series, this is not an arithmetic series because here we cannot find a common difference. Also, it's not a geometric series. That's because it does not have any common ratio. Now, next thing that we'll need to check if it is an Arithmetico-Geometric series or not. So here, if we consider from the first term as 1 squared, from the second term, if we get 2 squared, from the third term we take 3 squared, from the fourth term we pick 4 squared, then we see that these terms are not going to form an arithmetic progression. They are not an arithmetic progression. However, if we consider 1 from the first term, 1 over 3 from the second term, 1 over 3 squared from the third term, and 1 over 3 raised to the power of 4 from the fourth term, we'll immediately observe here that these sequences are going to form a geometric progression. That means this particular sequence has a common ratio equals to 1 over 3. Now, since it's forming a GP but not an AP, so we cannot say that the first infinite series or the original infinite series is an Arithmetico-Geometric series as well. So what we will do, we'll take this common ratio and we're going to multiply each terms with 1 over 3. So that means we have 1/3 of the sum of the infinite terms. This will be equals to, so let's take the first term 1 and multiply it with the common ratio 1 over 3. That's going to give us 1 over 3. Added to, next we will take the second term 2 squared over 3 and multiply it with 1/3 to get 2 squared over 3 squared. Then we'll take the third term 3 squared over 3 squared, but when we multiply it with 1 over 3, we'll get 3 squared over 3 cube. And we have the rest of the term. We're going to name this as number 2. Now what we'll do, we will subtract 2 from 1. So when we subtract 2 from 1, we're going to get 2/3 of the sum of the infinite terms. That will be equals to 1 added to. Now what we have, 2 squared minus 1 divided by 3. Added to 3 squared minus 2 squared divided by 3 squared. Added to 4 squared minus 3 squared divided by 3 cube, and the rest of the terms. So now we have 2/3 of sum of the infinite terms. This is going to be equals to 1 added to. So 2 squared, that's 4. 4 minus 1, that's going to be 3. We have 3 over 3. Added to, now 3 squared, that's 9. 9 minus 2 squared, that's 4. 9 minus 4, that's going to give us 5. We have 5 over 3 squared. Added to 16 minus 9, so that's going to give us 7. We have 7 over 3 cube. And we have the rest of the terms. Now, we have a new series here. So in the series, we see, let's look at this particular series here. The first term is 3 over 3, but we're only going to consider the numerator, which is 3. Then in the next term, we have 5 over 3 squared. Considering only the numerator, we have 5. Similarly, from the third term, considering only the numerator, we have 7. Now 3, 5, 7, as we can see, these terms are going to be in arithmetic progression. Next, what we'll do, we'll take the denominator. That means we'll take 1 over 3 from the first term, 1 over 3 squared from the second term, 1 over 3 cube from the third term of this particular series, and we see that these terms are going to be in geometric progression with a common ratio equals to 1 over 3. Now we have found out that this series, this particular portion of series here, it's composed of an arithmetic progression and a geometric progression. In other words, what we are saying here, that this series is actually an Arithmetico-Geometric series. So now that we have converted our original series after subtraction to a Arithmetico-Geometric series, only a certain portion of it, we are going to proceed by multiplying each terms again with the common ratio of the geometric progression, which is 1 over 3. So what we'll do, we're going to take 1 over 3 and multiply it with 2 over 3 of S infinity. So that's going to now give us, so we have the first term, that's 1. So 1 multiplied to 1 over 3, that gives us 1 over 3. Added to 3 over 3 multiplied to 1 over 3, so that's 3 over 3 squared. Added to 5 over 3 squared times 1 over 3, so that's 5 over 3 cube. And then we have the rest of the terms. We're going to name this series as number 4. Now what we'll do, we're going to subtract 4 from 3. Now on the left hand side, we have 2/3 of sum up to the infinite terms minus 2 over 9 times sum up to infinite terms. This is going to be equals to 1 added to. Now we take the second term of series number 3 and from here subtract the first term of series number 4. So 3 over 3 minus 1 over 3, that's going to give us 2 over 3. Added to 5 over 3 squared minus 3 over 3 squared, that's 2 over 3 squared. Added to 7 over 3 cube minus 5 over 3 cube, so that's 2 over 3 cube. And we have the rest of the terms. Now let's further simplify. So here we have 2/3 minus 2 9, so that's going to give us 4 over 9 of sum up to infinite terms. This will be equals to 1 added to. Now if we look at these sum, this is an infinite geometric series with the first term a equals to 2 over 3 and the common ratio that's equals to 1 over 3. And we know the sum to infinite terms of a geometric series that's given by a over 1 minus the common ratio r. So when you substitute these values, we have 2 over 3 divided by 1 minus 1 over 3. So that's going to give us a sum equals to 1. So that means we have 1 in this particular place of the series. Now we have 4 over 9 times sum of the infinite terms equals to 2. So sum of the infinite terms, that comes out to be equals to 9 over 2. So therefore, the sum up to infinite terms of the given infinite series, this sum comes out to be equals to 9 over